So when you happen to have a changing behavior, you have three different choices in terms of how to implement those changing behavior. The first choice could be using inheritance to support that changing behavior. So in this case, subclasses provide the changing behavior. And you want to use this scheme when changing behaviors are aligned only with subclasses. Okay. And also, you want to use it when changing behaviors depend on attributes on the subclasses. And this is what we have worked on in previous example. Example we have was that we have hourly employee type and salary employee type. And for computing monthly payment for employee types, we actually implemented. If you take a look at the code we have, this is the code that we have before. So here we have the hourly employee is basically computing the pay employee. So if you take a look at the employee class here, we have the abstract class, which contains pay employee method, and here subclasses, in this case hourly employee, implement its own the implementation. So this is the different behavior for hourly employee. And then we have a salaried employee here, which actually provides its own implementation for pay employee method. So this is a case that we have the changing behavior, in this case computing monthly payment to an employee in subclasses, because those computations are aligned with inheritance. Okay, so all subclasses of employee should have pay employee implementation, and those implementations are different. Okay, so that is one way of implementing changing behavior. Another way that you can use is to use interface to support that changing behavior. So in this case, classes implement the interface, and you use this scheme when changing behavior needs to be imposed to classes that are not related via inheritance. Suppose we have salaried employees and board members. So these are something that we're going to actually work on later on. Suppose if you need to compute and compute the bonuses for salaried employees and board members, certainly board member and the board of director, I guess, board of director and salaried employee, they are not really related by inheritance. Yet we need to support computing bonus. Okay, so in that case, we could actually use interface. So salaried employee will have implementation of the bonusable maybe interface, and then the director, board of director class also implement that interface. Okay, so again, we can actually take a look at how we can implement this one later on in our hands-on lab. The last one is actually using composition. So this is probably the most favored approach. So in this case, we are basically injecting changing behavior object that represent a changing behavior into a target class, and you use this scheme when runtime selection of the behavior is desired, or use it when views of the behavior is also desired. So since you can capture those changing behaviors in different classes, those classes could be actually used in other part of your applications. Okay, so we're going to actually look into all these approaches in our hands-on lab. Okay. All right, so what we want to do is take a look at the readme.txt file here. So this is what we want to accomplish today. Okay. So description, we have received a customer request that computing and paying monthly payment logic needs to be also supported in intern class, which is not a child class of employee class. So this might give and the way that we are going to compute the monthly payment for intern class is going to be something like this. Intern class has a number of hours worked with pay and number of hours worked without pay. And so what we're going to do for intern class is that we are going to multiply hourly rate and then number of hours worked with pay. So the key point in this case is that the logic for computing monthly payment cannot be now in the inheritance hierarchy. We cannot actually use inheritance hierarchy scheme because intern is not an employee. Okay, so that's what I said here. What this means is that logic now should be extracted into another class. In other words, we need to use composition instead of inheritance for varying behavior. So what we need to do is that, right now, this is actually using inheritance. So our employee is implementing pay employee method using this particular scheme, and the salaried employee has the scheme of just returning monthly salary. Now we need to actually support this pay employee method implementation intern class, and intern class is not a child class of employees, so we cannot actually use inheritance scheme. So what we're going to do is we are going to refactor our code to use composition. Okay, so employee HR system to start. So this is the same application as the employee HR system complete, which is the end result of Java OO example exercise that we did 3 weeks ago. So that is a starting project, and we're going to just refactor our code so that we could actually use this compute monthly payment logic to be injected into these classes. So we are basically converting inheritance-based scheme into composition-based scheme. Okay. And then we are going to also do something like, so this is an example where we are going to actually use interface. Okay, so we also received another customer request that computing and paying monthly bonus logic need to be added for salaried employee and board of directors. Okay. The salaried employee, the monthly bonus is computed as 1.5% of the monthly salary, and for board of directors, the bonus will be 2% of monthly stipend they receive. Okay. Again, what this means is that we cannot use inheritance since the board of director class and board of directors are not employees, so we cannot actually use inheritance scheme. Okay. So in this case, we could use again composition or interface, and in this example, we are going to use interface because the board of directors and salaried employees are not related by inheritance. So this is an example where we are going to use interface. Okay. All right, maybe I should actually remove this guy. Yeah, I think that's the code that I actually should have incomplete. Okay, so this one should be actually incomplete. I don't know why it's actually here. So I'm going to just move up here. Okay, and board of director class should be also domain here. Okay, yeah, looks like I work on the start project rather than a complete project. Salaried employee, let me just make sure. Oh, okay, so I'm gonna just remove this guy so that we can actually start from scratch. Yeah, I should actually clean that up, and I'll upload the new hands-on lab. Okay, and then here, okay, so I'm gonna just remove this code. Okay, all right. All right, okay, and I think we have a testing code. Yeah, so this testing code should be over here as well. So I'm going to move this guy right here. Okay, so we don't have that logic implemented. Okay, all right, so we're gonna actually try this one first. We're gonna actually convert inheritance scheme of paying monthly payment logic into composition. Okay, so what we are gonna do is we are going to create iPay computer interface with the following method. By the way, given the salaried employee and hourly employee and intern classes, they need to use a different set of arguments to compute the monthly pay. We need to actually pass them as a map object like this. Okay, so for example, hourly employee will use the number of hours worked and the hourly rate, while salaried employee has the monthly fixed salary, and intern class has the number of hours worked with pay and also the hourly rate. So those informations need to be passed to compute pay method. So the only way we can actually accept those arguments in a flexible fashion is using a map object like this. Okay. Then we're going to actually implement the classes for the hourly employee and salaried employee and intern. And then we are going to have pay computer object to be injected employee class, which is the abstract class for hourly employee and the salaried employee. And also we're going to actually inject it into the intern class. And of course we are going to actually write the testing code. Okay. Any questions in terms of how we're going to actually proceed? Okay, let me know if you have any questions before we move on. Okay, so let's do the work. So I'm gonna just, so this one should be, yeah. All right, so I am going to create, let's actually write the testing code first, okay? So we are going to have another package. So since we have this logic in domain classes, we do not have a testing code. So I'm going to why don't I actually create the testing code here first, and then I'm going to actually create the so I'm going to actually create a class, and this is going to be let's see here. I want to actually create the pay. I'm gonna just say pay package, and I'm going to say so I want to actually have for now I'm gonna just use the compute pay test, something like that. Okay. All right, so here I'm going to write the testing code, test. So should compute the monthly pay for, let's say, the hourly employee using composition, okay? Just to be clear, okay? So what we need to do is we are going to create employee object, the hourly employee object. So hourly employee and hourly employee and the new hourly employee object, and basically employee ID, I'm going to just say 1, and first name, whatever first name of your choice, and last name, Shin, and hourly rate is going to be $10, something like that. Okay. All right, so now we have created hourly employee. Okay. And what we need to do is we are going to inject some we need to actually create iPay computer object for the hourly employee. So we need to actually create it and inject it. Okay. So here we are going to create iPay computer, and we haven't created this interface yet. Okay, so I'm going to say iPay computer, and we are going to create the hourly version of the so we're going to say new pay computer for hourly employee. Okay, something like this. Okay, so now let's actually create the iPay computer interface. So this is going to be interface. So here we are going to, so I'm going to actually, So here, basically what we want to do is we actually see readme text file. So let me just, so basically what we want to create is public double compute pay, and we're going to actually receive pay arguments in the form of the map object. Okay, so we are going to have public double and the pay was that the compute pay. Okay, so it doesn't really matter, but compute pay. And we are going to receive a map object, and because we don't know the type of those arguments, we're going to actually make them as a string and string, string and string, and we're going to say string and the pay argument, something like this, string like this, and import the class. Okay, so we have this pay computer, and let's actually take a look at the basically we need to now create the pay computer for hourly employee. So idea is that we need to create this guy, and then we need to inject this one to hourly employee. Well, actually we could actually have this one to be injected in employee class, right? So we can actually say this one is instead of employee, we're gonna actually employee, and I'm gonna just say employee, and let's make sure we have import this class employee, and we're gonna just use a setter method. Okay, set, we are going to have set, I'm gonna just use I computer here, and then we're gonna actually pass this I pay computer object. So we actually inject this I pay computer object into employee class, and then basically we should be able to ask employee class. We haven't actually implemented all this one yet. I just want to actually give you a big picture in terms of how to use a composition. So we actually inject the computer pay computer for our employee object into the employee method, and then we should be able to say employee, and then we are going to say we could actually use the same the compute pay, and here, and we should be able to when we actually call the compute pay, we should actually create the map object here as well. Okay, so we probably have to create the map object. So the what we need for our employee is the number of hours worked, and then the hours hourly rate. Okay, so here we are going to create a map object, string, and this pay argument, and then it's going to be hash map, and I should say new hash map, and string. Yeah, I don't have to actually have this one if in Java 8, and like this, and make sure that we have imported all the classes, and then we are going to pass this pay arguments here. Okay, all right, and this one should be asserted. Okay, so I haven't actually created this pay arguments here, so basically I can say assert that this one should be close to, and let's say for now is $100, and delta is 10 cents, something like this, and let's make sure that this one is imported. And okay, so now we are going to actually okay, so let's actually make sure that we have this map object also created. I'm just trying to give you a big picture first, and then we will actually add this method. Okay, all right, so for this pay argument, so we are going to add the pay arguments, and we're going to actually add put, and so this is the hourly rate. Hourly rate is going to be some value, so we should be able to just use $10. Okay, so it is a string, so we're going to just use the 10. And then we also have two pay arguments, and we can actually put another one. In this case, is going to be the number of hours worked. Let's actually make sure that we have that information correctly. Okay, so number of hours worked per month. Okay, so that is the one. So number of hours worked per month, and we'll just say is 10 hours. Okay, and then it should actually return like this. Okay, so this is the logic that we want to test. So we create our employee object, And because it's a composition, we need to create an object that represent the logic of creating the computing monthly payment for then our hourly employees. So that is this class, which we are going to actually implement soon. And then we need to inject that object into employee class. We can actually inject in employee class because both hourly employee and the salary employee should have the this I pay computer object. So we are injecting an employee class instead of hourly employee or salary employee. Then we create a map object in which we are passing hourly rate and number of hours worked per month in terms of, oh, this one should be also a string, okay, like this, okay. All right, and then we are going to ask employee compute pay with a pay argument. So in this case, it's basically using this object. Okay. All right. So let's actually create. Yeah. So let me just expand okay. So I'm gonna just expand like this, and we are going to save all the changes. Now let's make the this pay computing per hourly employee class. So we're gonna create hourly employee. Yeah. So this one should be main. Yeah. But I'm gonna actually move that one later on. Okay. And so I am going to move up here. Okay, so what we need to do is, yeah, so this is basically what needs to be implemented. So let me just move this guy. Okay, so for our employee, we need to actually get those pay argument information extracted into the integer for the number of hours worked, and then double type for the hourly rate, and then we just return the multiplication of those. Okay, so we are going to actually do that. So here we are going to say we need to extract. We are going to actually create the int the number of hours. Let's actually get the number of hours worked. So that is in the in this class is number of hours worked as int type, and that should be pay argument, and we need to get, and the key is supposed to be the same thing, number of hours, like this. Okay, and since it returns a string, we need to actually parse this guy. So we are going to say, let me just expand this one, integer and parse int. Okay, and we need to pass this guy, and here. Okay, all right, so that is the number of hours worked per month, and then we need to get the double value of hourly rate. Okay, so that is the hourly rate. So I'm going to just copy this guy. Hourly rate should be again double parse double, and in this case the string is going to be, I'm going to just copy this part, like this, and then again this is going to be hourly rate. Oh, not this one. Yeah, integer pay arguments. And this one should be like this. Okay, and then it's going to be number of hours worked times and hourly rate, like this. So we have created this object. Okay, and this object will be injected into employee class. If you take a look at the our test code. Okay, so let's actually save the changes. We have created this guy, and it will be injected in employee class, and we don't have this setter method, so we're going to actually have this employee setter method. Yeah, first of all, employee class doesn't have this iPay computer either, right? So we need to have that type in employee class. Okay, so we are going to have let's say type employee, so it should be start. Okay, so I'm going to just move up here. So we need to have, just like we did life insurance provider and other things, we should have the type of, so I'm going to use the protected, and it's going to be iPay computer. So this is iPay computer, and I'm going to name it as iPay computer, like this. And we need a setter method. Yeah, so iPay computer, let's make sure that we import the class. Okay, and then we need a setter method. So we are going to have here source and setter method. So I need the iPay computer, this guy, just to set this guy, and I want to actually have it at the end. See here. Okay, so iPay computer. So I'm gonna just use that method right here. Okay. All right. So that is all set. Now we need to have this compute pay method in the employee class. Okay. So employee class. Again, employee class, we are going to have compute pay create method, and here yeah, this one should actually return double and pay argument. And basically what we need to do is, in this case, we are going to just call this iPay computer with and compute pay with the same argument. Okay, and let's save the changes. All right, so let's see what it doesn't like here. So the oh, maybe I should actually have static import here. Okay, and let's make sure that testing is okay. So it looks like we still have some compile errors. So Control M. I should do this. Okay, yeah, I think this is actually completion thing. So I'm gonna just, yeah, it was actually one of the. So let me just make sure this is the for now. Yeah, this is the completion, and I think I messed that up. So I'm gonna just do this guy, so that I'm just trying to make sure that the okay. So you know the infinite test is succeed. Okay. All right. So any questions at this point? So basically, what we did was, we basically refactored the inheritance-based changing behavior, using composition. So the part that we just did is we implemented computing monthly payment for hourly employee using composition. Okay, and we're going to actually do the same thing for salaried employee, and then we're going to actually also do for intern class. Any questions? Does this make sense? All right, so I'm going to actually stop right here and let you guys actually do this part. So I need another package here, and I'm going to move these classes into this. Same thing for pay computer. Okay. So basically what we need is we need to create implementation for salaried employee and also intern. Okay, we haven't created intern class yet. New. Okay, so let me continue. I'm going to actually implement the test and then the code for salaried employee. So basically I'm actually doing the same thing here. So test. So should compute monthly pay for salaried employee using composition. Okay, and code is supposed to be pretty similar. So instead of copying it, I'm actually writing line by line just to give you guys a sense of how things work. So we're going to actually create employee object and employee. This time we are going to create new the salaried employee, and employee ID 2, and first name I'll just say Sang 2, and last name Sang Shin 2, and monthly salary I'm gonna just say $1,000 like this. Okay, so we created the salaried employee. Okay, now what are we supposed to do next? Anybody give me a hint? What do you guys suggest? Anybody? Okay, basically we're gonna do the same thing. We're gonna create iPay computer object, which is now implementation for pay computer for salaried employees. So same thing here, iPay computer and iPay computer, and now we're gonna create the new pay computer for salaried employee. By the way, whenever I say composition, I'm talking about the strategy pattern. Okay. All right. So now we're going to actually again employee. We are going to have a setter method. So I'm going to just use the same setter method. Yeah. Since we actually included in the employee class, I should be able to have set pay computer object like this. Okay. Code completion should work fine. And then I'm going to create the map object, which in this case is just a single attribute, which is fixed monthly salary or something like that. Okay. All right. So let's create the map object, string, and pay argument, and new hash map. Again, if you're using Java 8, you should be able to do just like this without specifying the type, and then pay argument, and we need to add put, and put, and here is going to be I forgot what the salaried employee, so Control Shift T. Let's find the salaried employee. In this case, we need to actually have a start. Okay, so salaried employee has a monthly salary field. Okay, so that's what I need here. So monthly salary, and we are going to set it to 1,000. Okay. Yeah, so in this case for salaried employee, yeah, we set it, and yeah, so this is probably a little bit of duplication. We are passing monthly salary as an argument as well. Okay, and then we are going to assert that, and employee, and again compute pay, passing the pay argument should be close to, and it should be $1,000, right? And delta is 10 cents, like this. Okay, and now we need to provide implementation of pay computer for salaried employee, right? Okay, so create this class, src main, and finish here. And this is the implementation of iPay computer, so it already knows that it needs to implement compute pay. So let me just delete this guy, and what we need is, basically we are going to return double, and the double, actually in this case we could just return the payment pay argument, and the get, and the key is monthly salary, and this is returning the string, right? So we need to convert it to double. So we are going to use double parse double, and basically we are going to pass the result of calling this guy right here. Okay, and let's save the changes, and testing succeed. Okay, so we verify that the we can compute the monthly salary for salaried employees, the $1,000. Okay. All right, so that is pretty much what we can do for employee test. Now we can do the same thing for intern class as well, right? So let's actually create the intern test as well. So I'm going to say test. We haven't created intern test yet, but if you take a look at the readme.txt file, so intern class, the number of hours worked with pay and the number of hours worked without pay, and it does have an hourly rate. So the logic of computing monthly pay for intern is number of hours worked with pay times hourly rate. Okay, it's just an example of different behavior for computing monthly payment. Okay. All right, so let's write the testing code first. So basically, should compute and monthly pay for intern using composition. Okay. Here, we are going to now create the intern class. We don't have intern class yet, so we need to create that. Intern, new intern, the class. So intern class should have the hourly rate as well as the number of hours worked with pay and number of hours worked without pay. Okay. All right. So I am going to just create intern class, and then we are going to create again I pay computer, and I pay computer, and we need to create an object that represent computing monthly payment for intern. So we're gonna say new, and we're gonna say pay computer for intern, like this. Okay, and this time we need to inject that object into intern class. Okay, so we're gonna say intern set. Again, I'm gonna use a setter method. Set I pay computer, and we just pass this I computer object. Okay, like this, and then that object is injected, and then we are going to create the map object just like what we did. So let's copy it, and then I'm going to just move it down here. All right, pay argument, and then what we need to do is we need to actually set two attribute. One is the hourly rate, and the other one is number of hours worked per month with pay. Okay. All right, so I'm going to just copy these two here because we are going to be using pretty similar fields. So hourly rate is the same thing, and number of hours worked with per month with pay. Okay. Again, we're going to just use 10, and then we are going to compute. So intern, and then compute pay, and here we are going to pay argument, and then that should be the $1,000 as well. So assert that, and this one should be close to and $1,000, and delta is 10 cents, like this. Okay, so this is the testing code. Okay, so again, we are doing TDD style development, in which we write the testing code first, and then we are going to write target classes, and then we can actually make sure that testing succeed. Okay, so let's actually handle the compiler problem. So we don't have any intern class, so we're going to actually create intern class. Okay, so I want to create in domain class. Yeah, should be main and finish. Okay, so here what we need is basically private and int number of hours worked. Okay, so let me just move this guy here, and we say hourly rate and number of, okay, so this one is number of hours worked, and we should have int number of hours worked without pay, and then we should have private and double and hourly rate, and we only care about the number of hours worked per month with pay. Okay, so this is the intern class. Okay, so now we need to have we need to create pay computer for intern. So let's create the pay computer for intern class. Okay, all right, and this one is supposed to be, yeah, so this one should be basically we need to have int number of hours, I'm gonna just have here number of hourly rate is, and number of hours worked. So I'm gonna just have this one also here. Oh, so this is double and int number of hours worked. Okay, and okay, so let me just delete this guy, and basically it should be hourly rate times number of hours worked with pay, like this. Okay, so now we're gonna actually compute this guy from this map object. So pay arguments and get, and should be, and this hourly rate, right? So it should be hourly rate here. Okay, and then we need to parse it because this is a string, so we are going to double parse double, and we need to just pass this result of this guy right here. And this one is the same thing, so it's going to be, oh, this is int type, so it's going to be integer parse int, and the one we are going to pass is this part, and then we'll change the we'll change this one, should be this guy. All right, so that should be providing pay computer for intern class, which captures varying behavior, in this case computing payment, monthly payment for intern class. Okay, all right, so we did that. Now we need to actually set this guy, the to intern class. So we need to have we need to create this method. Okay, so here, and so that is intern class, and so here we need to have I pay computer field here, private, and I pay computer here, and this is basically control D, and with this, and I pay oops, computer goes I pay computer, like this. Okay, all right, so we did that, and the last one we need is we need the method in intern class. Okay, so we're going to create the compute pay. All right, okay, so here it should return double, and basically the only thing we do is we're going to use this injected object. So we're going to say I pay computer, and it should have compute the pay, and we are passing this pay argument, and that should work fine. So I need to actually import assert that as well here. Okay, so let's make sure that testing succeed. Okay, so testing succeeded, right? Okay, so I have implemented pay computer. I'm sorry, compute monthly payment logic for hourly employee and salaried employee and intern class using composition. In this case, intern class is not in the hierarchy of employee class. Okay, all right, so I'm going to give you guys about 10 minutes to finish up to this point. Now, what we need to do is we need to actually go back and if you take a look at the company.java here, what we wanted was being able to compute the total amount that are paid to everyone. So in this case, we are only interested in employee class. We are not interested in intern class. Okay. However, we cannot actually call this one anymore, right? So basically, what we need to do is we need to actually pass that map object, right? Yeah. So this one employee should be not not pay. It's actually compute pay, and we need to actually pass some kind of map object, right? Okay. So what we need to do is we need to create this pay argument object depending on employee type. If it is a salaried employee, and this pay argument object should contain just the fixed monthly salary, key value pair. And if it is hourly employee, then it should contain two attributes, two key value pair. One is hourly rate, and the other one is the number of hours worked per month. Okay, so we might actually create a method for this. So we're going to say create, we'll say generate pay argument, and we probably have to pass employee so that correct the argument set gets created. So we are going to create here method. Okay, so basically what we are going to do is we have to check whether this is a salaried employee or hourly employee, right? So we are going to check if employee instance of hourly employee like this, and then yeah, we're gonna actually create the this hash map. So let's say map string and pay argument, and it's going to be new hash map, and import the class. Okay, and so basically we need to extract, we need to create we need to create the map object that contains the hourly rate and the number of hours worked. Okay, so here we are going to first of all, I'm gonna actually do line by line. So if it is employee, then we have to actually convert that type into hourly employee. Okay, so we are going to have hourly employee and hourly employee, and it's going to be type of hourly employee, and this should be employee like this. Okay, and then we need to extract the hourly rate. So hourly rate is double hourly rate, and we are going to say employee. In this case, yeah, we should say hourly employee, because hourly employee is the only one who can get those the hourly rate. Okay, so we don't have the getter method for that, so we need to actually add that. Okay, so let's actually do that first. So hourly employee for here. So we are going to have getter method for this. Okay. Yeah, we need getter method on both. So Control Shift S, select getters and setters. We need getter method on both of those, and we want to add it at the end. Okay, so we should have getter and setter methods. So now I should be able to say get hourly rate like this. Okay. All right. Now we need to convert this guy into a string and then add it to the map object. Okay. So let's convert into this string. I'm gonna actually do step by step. So it's a string, and it's hourly rate. I'm gonna just say string, and then it's going to be the string value of, and this is going to be hourly rate like this. Okay, and then we should be able to add to the map object. So pay argument, and we're gonna say put, and the key is the hourly rate. Key is hourly rate, and the value is going to be this hourly string like this. Okay. All right. You know, you don't have to have these 4 lines of code. I'm just actually doing step by step. That's all. Okay. Just to show you what are we doing here. All right. Now that's for the hourly employee case. Now we want to actually do the same thing for the salaried employee. Employee instance of, and salaried employee, and we are going to do the same thing here. So we have to create salaried employee, salaried employee, new so we have to again decast it, salaried employee. It should be employee like this, and then we need to create double monthly salary. I think that was actually what salaried employee, that is a monthly salary. Okay, so that is going to be monthly salary, and salaried employee, and we're gonna get. All right, so we don't have any getter method. Okay, so we need to create salaried employee getter method. So here, Control Shift S. Let's create the getter method, and I need to have it at the end. Okay. All right, so we got the getter method. So here, let's say get monthly salary, right? And then we are going to make a string the monthly salary string, and we are going to convert to string. So value of, and that should be monthly salary double. Okay, and then we create the pay argument, and put, and that should be monthly salary string, and then the value is supposed to be monthly salary string object that we just created like this, and then of course we need to pass like this. Okay. All right, so that should be working okay. So let's actually make sure that we have a test code. Okay, let's save all these changes, and our testing code is kind of disabled, so let's actually make sure our testing code is in so this the company. So where was a company test? Okay, so this is the one that we have. So here we are going to uncomment, and let's see. All right, so that worked. Okay, so it is actually now we created 3 employee types, the 2 hourly employee and 1 salaried employee. We add them up, and the cost is computed as 1. Oh, it failed. I said it too quickly. All right, so let's see what it failed. All right, so I'm gonna say Alt Shift XT. I'm gonna just I'm gonna just run this guy. Oh, we got the null point exception. Anybody knows why? Anybody? Whenever you experience null point exception, we can certainly, this is when we are trying to compute compute, in this case is the employee object, and whenever we got null point exception, that means something has not been set. What could be the reason? Anybody? Yeah, so exception happening, from the invocation of those, if you actually see the test failure, so let's actually run the test again. T here is actually calling here so compute total payment here, and then is employee. So if you go over here, it's actually calling the compute pay, and then is calling here is actually calling iComputer, but basically this iComputer was not set. In our test cases for each individual classes, we actually used the setter method to set it up, but in the company class we didn't. So if you see this company class, we did not set those iComputer object into the employee object. Okay, so that is the reason. So we are going to before we are calling compute pay method of employee, we need to inject those changing behavior the object. Okay, so here we are going to say employee, and we need to set a method, set iPayComputer, and this is where we need to actually pass a particular the object depending on the type of employee. If it is salaried employee, we need to pass salary employee version of that object, compute the pay computer object. If it is the hourly employee, we need to pass hourly employee version of it. So here we are going to actually create, we're going to just use the method create the pay computer object depending on employee. So I'm going to pass employee here, and we are going to create this method. Okay, so here basically again depending on if employee type is, let me just delete this line. So here basically if employee, I'm going to just copy this code. If it is, then we are going to create return yes, so yeah, we'll just say iComputer object. Oops, sorry. Okay, let's just say iPayComputer, iPayComputer, like this. Okay. And what we can do is, we are going to return this iPayComputer object here, and then what we can do is, depending on whether employee is hourly type, or there could be actually different employee type, but in this case we have only 2, right? So we're going to just use just use like this, employee instance of, and then if that's the case, we're going to create a new new hourly pay hourly employee object. Otherwise, and new pay computer, the pay computer for salary, pay computer for salary. Okay, here we go. And then we are going to just return. So we should be able to just return like this and delete this guy. Okay, so let's save the change. Oh, okay, still fails. All right, so that is interesting. We set the we basically create the new pay computer. So if it's hourly employee, we are creating hourly employee object, and otherwise then we actually set. Okay, so let's see what is failing. Okay, so I'm gonna say this time we should not actually experience null pointer exception, but let's see actually what happens. Alt Shift XT. Oh, we have another null pointer exception. So in this case, the parse int alright, so let's take a look at this one. Oh, that's not what I want. This one. Okay, so here this is pay computer for hourly employee, and then this is integer number of hours worked per month. All right, I'll let you guys actually work up to this point. In the meantime, I'm gonna actually find out what's going on here. Okay, so I'll let you guys actually finish up the exercise up to this point. Yeah, we didn't actually set the number of our works, the map object, so that's why. So here. So we did that. So we are going to have int number of hours worked per month, and then that is hourly employee, and get number of hours worked here, and then we are going to we create an int. Yes, so I'm going to just have like this, and we're going to create a string, and number of hours worked string, and then we're going to string value of, it's going to be like this, and then like this, and then we are going to pay arguments, then put, and the string should be number of hours worked, and the value is going to be the string object. Okay, that's Turing. All right, that should work. Okay, so that succeed the testing. So let me proceed with the last task that was requested, and I'll let you guys actually do the lab. The last task is actually using interface. Okay, so if you take a look at the README file, we also received another customer request that computing and paying monthly bonus logic needs to be added only for salaried employee and board of directors. Okay, so for salaried employee, the monthly bonus is computed as 1.5% of the monthly salary, and for board of directors, the bonus will be 2% of the monthly stipend. So they receive monthly stipend, and the bonus is going to be 2% of it. Okay. Now we cannot use inheritance because board of director and the salaried employee, they are not really related by inheritance. Okay. So we could either use composition or interface. Okay. Since we have seen the example of using composition for computing monthly payment, we're gonna use interface in this case, right? So we'll use interface because a board of director and salaried employee are not related by inheritance. Okay. All right. So let's write the testing code. So here I'm going to write. So I'm going to actually write the testing class, new class, and I'm going to just make a package com JPassion and HR and the bonus. Okay, and the name of the class is bonus. Yeah, so in this case I'm gonna just say bonus test. Okay. All right, so what we want to do is let's write the testing logic. So should compute bonus for salaried employee using interface. Okay. All right. So basically, the salaried employee and the board of director, they use a different logic for computing bonus. Okay. All right. So here we're going to use interface. Okay. All right. So we are going to create the salaried employee. So salaried employee, new salaried employee. Again, employee ID 1 and the first name Sang and last name Shin and monthly salary $1,000. This. Okay. All right. So now what we want to do is, we want to actually make this employee object to be the type of actually the bonus able. Okay, some companies using able as the convention for interface, or some companies use capital I. So I'm going to use a capital I convention. The compute bonus. So this is the interface bonus. And basically in this logic, in this interface, we should be able to say salaried employee, and we are going to be able to say compute bonus. Okay, something like this. And then we should be able to assert that this one is, let's say, it's actually 2% of the salary, so it should be 1,000 times 2%. Okay, I should say close to, and delta is 10 cents, like this. Okay, so I'm gonna just static method. Okay, so now we need to create this iCompute bonus interface. So we are going to create interface, and basically that should, I'm gonna just create test and move it later on. And here basically we are going to call compute bonus method. So here we are going to create create compute bonus. Okay, and it should return double, public double, like double, and that is interface. Okay, let's see why it doesn't like. Okay. New salaried employee. So that's what it says. This match could not convert from salaried employee to iCompute. Oh, okay. So what we need to do is we need to actually have salaried employee class to be the type of this guy. Okay. So salaried employee should be the implements. Implements implement like this, and then we need to implement the I compute bonus. Okay, so that we should have that. Now we should actually implement it. Why did it say implement import? Oh, we have to import. Okay, and then we are going to add an implementing method. So that is this guy. Okay. All right. So basically, we are going to return. The logic is going to be monthly salary times 2%. Okay. And let's make sure it passed the testing. So that is successful. And I'm going to actually refactor this guy, Alt-Shift-T, and we want to create the constant, and it should be 2%, like that. Okay, and still should work fine. All right, so that is the logic of implementing computation of the bonus for salaried employee. And we need to do the same thing for board of directors. And we don't have a board of directors class, so we're going to actually create those things as we move on. So we're going to create test. All right, so should compute bonus for board of director using interface. Okay, so here we're going to board of director. I'm going to call him board of director, and here we're going to just create the board of director, and we'll just pass the stipend, $1,000. Okay, so it's a monthly stipend. Okay, all right, so let's create the board of director class. So here, create a board of director class. So it should be in the domain package. Okay, and you should just have a monthly stipend, private double monthly stipend. Okay, and let's create a constructor. So we are going to have this constructor. So create the constructor. Okay, so here is going to be the monthly stipend. So I'm going to just move up this guy here, and it should be monthly stipend, and this monthly stipend. Okay, so we were able to create the board of director class. Okay, and now we are going to compute. So this one should be board of directors should be also I compute bonus type. Okay, so here I'm gonna copy I compute bonus type, and we have to make sure we are going to add cast. Yeah, we need to actually implement. Yeah, so let the board of director implement I compute bonus. Okay, all right. So now we are going to implement unimplement method, and this one should be the monthly. Oh, I think I actually changed the reversed it. If you take a look at the readme, the text file, the salary employee is 0.5% and board of director is 2%. Okay, so I did compute in reverse. Okay, so this is the one that actually 2%. Okay, 0.2, and this is the 2%. Oops. Save. So this one, yeah, so this one should be actually 0.15, and this one should be 0.02 and 0.1, like this. Okay. oh, what am I talking about? Yeah, this is the one that actually creating board of director, and this is the assert statement. This is the one I need. Assert that, and board of director, and compute bonus should be close to, and should be 1000 times 0.2, and delta is 10 cents, like this. Okay, so let's see what is complaining about. This one says syntax. Oh, syntax is broken. Okay, yeah. Okay. Okay, so okay, so I actually in the salaried employee, I did not actually use, I should not use this one. It should actually use 0015. Okay, so this one is okay. Extract constant 1.5%. Okay, and now save the change, and the test to succeed. Okay, so let's just make sure that I got the classes in the right. So yeah, there's just the I compute bonus. Yeah, so I want to actually create another package. New here package. Com JPassion HR bonus package, and we are going to this is a compute bonus. Yes, that's the only thing I think we need to actually move up there. And bonus test, that's actually basically what we just did. All right, so we are all set. So if you take a look at readme.txt file, we were able to compute bonus by implementing interface in the classes, in this case salary employee class and the board of director class. Okay, all right, let me just stop.